All right, so welcome everyone. It's my pleasure tonight to announce or to welcome you, I guess, to our Q&A as part of the feature week that we've been running with MitoQ as part of our look into mitochondrial dysfunction in multiple sclerosis. As you may have seen across the week, we've had interviews with Greg Macpherson, who's the CEO of MitoQ, Professor Mike Murphy from Cambridge, and also a personal perspective from Karen, who's a person with MS who's been using MitoQ. And thankfully, I can say that they're all joining us tonight. So, Greg, I might hand over to you just to start a little bit of an introduction.
Great. Well, good day, everybody. Good evening. Thanks for joining us tonight. My name is Greg Macpherson. I'm the CEO of MitoQ. It's been my pleasure to work with the company now for I guess a little over 4 years, and over that time, we have brought MitoQ and introduced it to a range of people. And we got interested in MS almost right at the start, and that was relating to a wee trial that popped out on a paper, and a bunch of news sites picked up on it, and people picked up on it as well and started trialing it. And it's been quite an interesting journey to date, and I guess I'll answer a bunch of questions tonight, and hopefully just tell you a little bit about what we've done, and what research is happening, and where we're looking to go forward. Thank you.
Yeah, fantastic. Mike, I might get you to introduce yourself as well.
Hi, my name is Mike Murphy. I'm a researcher in Cambridge working for the Medical Research Council now. I used to live and work in New Zealand, and there I was working with Rob Smith in the University of Otago in the South Island. And there we developed some ways of addressing oxidative damage to mitochondria. This is targeting molecules to mitochondria very selectively, and showed that this could work very nicely in patients. And this was interesting because oxidative damage is thought to contribute to a very large number of diseases, including multiple sclerosis, of course. And previous antioxidants haven't been so effective. And one of the reasons they weren't so effective, we think, maybe because they weren't going to the mitochondria, which is a major source of the oxidative damage that contributes to the diseases. So by making these molecules go to mitochondria, we had a better way of protecting. And so then we've tried this in many different animal models of various diseases, and also in a small number of human trials as well. It's shown to have some efficacy in these. Of course, we've no human trials yet on multiple sclerosis, but I think we have a lot of anecdotal reports of people who are using it. So we'll find out more about that later on today.
All right, fantastic. So I might open it up now to the floor to ask some questions, and I'm going to start with you, Andrew, because I know that you have been extremely excited about this event, a sort of topic that's near and dear to your heart. So I might chuck it over to you to ask the first question.
Okay, I'll try and make it a simple question. I'd like to ask Mike a question later, which is more technical, but I'll try and avoid making a big mess of the whole night for you. Because it's simply the simple question is, from the background, I had a very big MS attack a couple of years ago. I'd been taking a low dose of coenzyme Q10, and I then ramped that up to 750 milligrams a night. You probably know whose product it was. They start with a B. It's a practitioner brand here. And it's mixed with vitamin E. And I found tremendous benefit from taking that much, much higher dose, but I had to find the dose myself to find a level that worked. And I found 750 milligrams a night works. But your product, obviously playing around with the gradient, is hopefully going to make it work better getting into the mitochondria. So how do I work out equivalence to actually know how much of your product I should be taking relative to the brand that works for me now, but I take rather a lot of?
I might answer that. It's actually very difficult to do that. So the short and probably unsatisfactory answer is that by self-medication and seeing what works for you. The problem is that the uptake and distribution of these molecules is so different that there's no rational way of extrapolating from one to the other. Even if you were to say a certain amount, if you were to give you various doses and then take a biopsy and measure how much is in the mitochondria, technically that would be quite difficult to do for various reasons. And even then, the doses in the mitochondria might not be equivalent. So I'm afraid the answer is to trial it and see which works better. for you. I'm afraid it's just not a good answer, but that's
Okay.
that's the true answer.
Okay. The second part of that question is I don't just take the coenzyme Q10 because I don't feel that's enough. I understand it needs to get into the mitochondria and it's going to influence the electron transport chain. But to get the ADP into the mitochondria and the ATP back out, you've got to have some sort of shuttle to help it go across. And my understanding, and you can correct me, is that needs acetyl-L-carnitine to act as the shuttle to help you get the ADP and the ATP in and out. How do you deal with that aspect of actually getting the ATP that's formed back out into the cell properly, so you can do the other functions?
It's a little bit different from that because the carnitine, what that actually does, the carnitine you can eat in your diet, that helps you burn fat. So the fat that you eat the carnitine helps get that into mitochondria to burn it. And that makes the ATP there inside the mitochondria. But there's a separate shuttle system that's a protein in the mitochondrial membrane that exports the ATP once it's made. So the carnitine is not involved in the ATP. It's further upstream in helping you burn fat.
That's fine. That's good. Somebody else can have a go. I've got a big question for Mike later, but give everybody else a go.
Okay, I might jump in with, just because there's a link to one of the questions that was submitted online, and actually a couple of people asked this question, was related to whether diet could possibly be another way of improving mitochondrial function. And a couple of people suggested this is a big part of Dr. Terry Weil's recommendations. Does anyone have any sort of comment on that?
So we're talking about Dr. Weil's diet? Or...
Yeah, well, just, I mean, not necessarily that one in particular, but whether diet and any sort of diet modifications can be a way of, I guess, reducing oxidative stress or improving mitochondrial function, or reducing mitochondrial dysfunction, I guess.
But yeah, from what I understand, Dr. Weil's diet, there's a doctor in Australia as well, I believe, who is going to diet.
Yeah, Dr. George Jelinek also is a big one on dietary modifications for MS management.
Yeah, absolutely. So from what I understand, for some people there's quite significant benefit from following those protocols.
I've tried different diets, if you don't mind me chatting here for a second.
No, go for it.
The Terry Weil's diet's quite difficult for a lot of people with MS because it's very, very, it's a huge amount of food. It's absolutely a huge amount of food. And a lot of people with MS end up with constipation problems and things like that anyway. The diet, I have tried various diets and I've had a lot of food allergy tests and things like that. And the best diet that I was on that I really need to seriously go back on was a ketogenic diet, which was a high-fat diet with a low carbohydrate. And working out the macros of what my best proportion of fat to protein and carbohydrate. And on it, I was extremely functional, like I was very, very fit. Had a lot of energy, lost a lot of weight. And I guess the reason why certain diets work for people is that once again, you're working on the cells. So you're sort of clearing out all the contaminants that bug your system by doing the food allergy tests and removing those things that slow everything down. And I guess the high-fat diet, I don't know why it worked particularly well for me, but I know that it was used before medications were available for epileptic children in about the 1920s, because it works very well in producing ketones, and ketones feed the nervous system. So I did that diet for probably 18 months, and it was really effective. But of course, I'm human, so I kind of went off the rails a bit with it, which is I'm really kicking myself. I wish I hadn't. But it's in combination with MitoQ, I think, worked very well because, once again, I think my cells were working well. I'm having issues at the moment with my health, and the only thing, anyway, I've seen endocrinologists and I've seen my neurologist, and I've just come back from having another lot of MRI scans done in Sydney. And I haven't got the results yet, but the one common denominator that every doctor I've seen, the endocrinologist or the neurologist or my GP or a naturopath, they've all said that my blood cells are strange. It's the only thing they can say. They're not anemic, they're odd shapes, they don't seem to be normal, and everyone's just saying, let's check this again in 6 months and see if this somehow corrects. So I think, we're looking at multiple sclerosis with damage to the nervous system and everything. It once again boils down to very much to a very fundamental and cellular level that is the big drawback that's stopping us from all sort of picking up the energy. Anyway,
yeah, definitely. Thanks for sharing that, Karen. I think, I mean, we all know, and from previous Q&As we've had, we could spend all our time talking about different diets and their effect on MS, but we'll try and bring it back to talking about mitochondria and MitoQ. I might throw it open to the other guys here, Brad, Justin, Laura. You guys have any questions that you'd like to pose to Mark or Craig? Not at the moment. I'm happy to jump in. I've got a whole list. Well, I might follow on then from another one that was asked online, which I guess we've talked quite a bit about there being evidence for mitochondrial dysfunction in MS and also in a range of other conditions. Someone asked, what are the causes of mitochondrial dysfunction? And I might link that to another question that was asked as to whether there was any link to infection, in particular the infection with chlamydia pneumoniae, and whether that is implicated at all in this.
You want me to start with that? Shall I respond to that, Brad?
Yeah, go for it, Mike.
Okay. Well, the origins of mitochondrial dysfunction are sort of simple and complicated, like many things. What we know is that if mitochondria get damaged, then they're not functioning so well. And that can happen from genetic causes. You could inherit mutations in the mitochondria put together so well. What happens in things like MS is less clear. Certainly, as we age, our mitochondria aren't functioning as well. And whether certain situations of damage or accelerated accumulated damage contribute, that seems likely. But also, of course, mitochondria are very much integrated into the whole way the cell works. And so the way the cells change with time also affects the way the mitochondria change, and that feeds back to the cell. So it's an area we don't know such a huge amount at the moment. But mitochondrial dysfunction in the crude sense of being like a car engine, it just doesn't work, and then that isn't getting in. It's probably not as simple as that in most situations, because that would be quite a devastating situation. What's likely happening, we think, is that mitochondria are central to many ways in which the body responds to inflammation and infection, and that's the way that the body responds by switching on the immune system so that the cell can respond. Mitochondria seem to be central to that. This is quite recent research, and so my gut feeling would be that in MS and other autoimmune diseases, it's the mitochondrial links into the way the body responds to infections and it starts attacking itself or mimics an infection, and the immune system gets inadvertently switched on. That, I suspect, could be a strong component of that. And in particular, that mitochondrial oxidative damage seems to be part of the signaling process, or the normal signaling process. But of course, we know so little about it that we're a bit in the dark, and it's a bit that we're trying to see what works. And if something like MitoQ assists that, and clinical trials show that in the future, then that also gives a point about some other ways that we can attack multiple sclerosis and related diseases. But this is at a very much a research level at this stage. We don't fully understand the mechanisms at all.
Okay. Can I ask, I'm going to follow that up and I'll let other people jump in a sec. I'm going to ask a really naive question. Is it possible to monitor levels of mitochondria function in people, and sort of what are the ways that you would go about doing that?
Yeah, it's not a naive question. It's actually a very challenging question. So in experimental situations, even we do a lot of experiments, say, on transplant organs, where we can take out, in some cases, a human kidney or a human heart. Even in those situations where you have the isolated organ, it can be quite challenging to measure the function of mitochondria. We can do that in various ways by taking biopsies and measuring the amount of energy that they're able to generate. And you can measure how much oxygen they consume. But to do it in a patient, because presumably most patients don't want us to take out bits of their hearts and homogenize them in liquid nitrogen and things like that. So it's very hard to know in patients. So you're always looking for quite indirect measures in patients. So this could be as simple as measuring someone on doing exercise or doing a fixed amount of exercise. Some situations you can do magnetic resonance scanning, where you look at the energy inside mitochondria, but you have to go inside like an MRI machine, where you look at just the specific molecule. So that's one way. But of course, this is not available generally, and it's only used in experiments, used routinely. So people tend to use indirect measures, where they would look at what's in the blood, because obviously you can measure most easily the blood and the urine. People don't really want to give muscle biopsies or anything so routine. You can measure blood, you can measure urine. There you can measure a few things, like, for example, lactic acid would build up if your mitochondria aren't working very well, and that will give you some readouts. But to be honest, these are quite crude readouts, and also because it's mixed through the whole body and it's diluted, makes it quite difficult to be sure what's really going on. So I'm afraid the answer again is actually a very good question, but it would be great if we had a simple readout. There's some colleagues in the University of Alabama in the States, that they're developing ways of assessing blood cells, so not the red blood cells, but the white blood cells. If you take them from a patient and assess how well they're functioning in various machines that measure how well the mitochondria are working in those cells, that might give us some indication of how the mitochondria are working. But of course, the issue there is that that's just those cells, the white blood cells, which might be useful, it might not be useful, and we need still to see how this works out. But there's some way people are looking, but it's quite challenging, I'm afraid.
Okay. Fantastic. Thank you. All right, I'm going to throw it back over to the participants. Does anyone want to jump in with a question?
Can I?
I will let you ask your question, Andrew, but I'll let Brad jump in if he's got one.
Okay, I'll try not to go on about it. Mike, in your second post today, you said that you felt that the feelings of fatigue that people had were really the brain causing the impression that you were fatigued, and it was a signalling issue. And to put that in the context of the question is, when I became very ill, 2 chambers of my heart actually stopped beating. So you talked about the idea that your heart would stop beating. Yet my arteries were as clear as a whistle. There was nothing wrong with them at all. I didn't require ablation or anything like that to restart them, but I simply just stopped beating. And so I was nearly dead. That's the impression in the hospital. But I managed to get out of it, and I do thank coenzyme Q10 in part for getting me back out of that. But it caused me to read a number of works, in particular one by a woman called Professor Joanne Ingwald, who is may not be still doing it, but was in charge of the laboratory at the Brigham and Women's Hospital in Massachusetts, in Boston, Massachusetts. And she wrote a very good work which said that the opposite of what you said. And she said the energy pools will actually deplete if you have an ischemic condition and you can't recycle ATP back into ATP. She said will quickly break down into the purines. And when that happens, your energy pool is gone. And she said it relied on having an ischemic condition, whereas if it was hypoxic, it didn't actually happen. But if it was ischemic, it did. And I found a very interesting book, but it sort of runs very counter to what you're actually saying about it being a signalling issue. It suggests it's a much more metabolic issue if you actually can't manufacture ATP, and gradually it gets into this cycle that gets worse and worse, which is what it feels to me has happened to my heart. And those conditions of ischemia, if we say the heart muscle was one example, another one would be a muscle called the piriformis, which is deep inside your buttocks. And I ended up with what they call piriformis syndrome. And there's a number of ways you can get that. Effectively, it spasms and squeezes your sciatic nerve. But the way to relieve that was actually, after I recovered, was still required injections of cortisone into the membrane over the muscle. And that gave me great relief. But from what I can read, that piriformis syndrome can be caused by an ischemic condition being established. So if you've actually got a problem with the blood flow, with the vasculature, and you're not getting enough oxygen, then that can cause that rapid depletion of ATP down into purines, and then they're lost once they go to AMP and below, and they're not available quickly to re-energise you. And that struck me as a more logical idea than a signalling question.
Both are, from my view, would be that both views would be true. So what we're looking at in, say, an ischemic insult is that you're squeezing off the oxygen and the fuel supply to the muscle. So in those situations, it's like having a block in the fuel line going into an engine. In that situation, you're obviously not going to be able to drive. So that's a very extreme situation, and it's one that's a bit, we reckon, is simpler to understand. So you're not getting the fuel in, you're not getting the oxygen in to burn the fuel, therefore you're not able to make the ATP. The ATP gets lost, as you're saying, by purine breakdown, and therefore that heart muscle or other muscles will have big problems. So this is what we would say is a very logical, simple situation, like in angina, any ischemic episode, often during organ storage for transplantation. But this is something that we do understand, this fairly simple metabolic damage. But what I was referring to was not that, which you're completely right about, but in the other situations where it's less clear, the general feelings of fatigue, say in chronic fatigue syndrome, which are global, or the feelings of fatigue that you have when you have something like flu, that if you measured the ATP levels in your muscles for someone who's got flu or someone who feels exhausted, the energy would still be there, the mitochondria is still working. What we don't understand is why the body is acting as in this way. So what's happening there is that when energy levels go, we don't fully understand what's going on in those situations. My feeling would be that the mitochondria are acting as a sensor of whether you need to switch an inflammation and whether you need to stop the body doing things to switch it over. So my gut feeling would be that some situations that you're getting in things like chronic fatigue and perhaps aspects of multiple sclerosis prior to damage are related to some of these. But your point is that both of what you're saying is completely correct. I would view what I'm saying is worth exploring because it's clearly not the extreme damage to mitochondria that you see in ischemic events. But later on, there will be extreme damage following inflammatory damage, in which case the mitochondria or the nerve cells are gone.
It just strikes me, I accept what you say, it just strikes me that it would be useful to check for what I described, and the way I can only see to describe that is actually not to look in the blood, which is to look in the blood, is to look at the uric acid level, because if that's depleted, that's the last step in the metabolism of purine, so you're losing the purine, so that would be a sign that you don't have sufficient purines to actually keep the system functioning properly. But I don't know what your test would be for your approach. And in the meantime, I could have sat in hospital and dropped dead because the heart could have just continued to fail to function if I didn't take my own Q10.
Sure. Again, I would say they're two separate things, one of a chronic illness and one an acute. But again, I'm not a physician, so you need to talk to what the doctors would look for would be acute situations like that and try and treat that.
You don't. To be honest, they don't.
Okay. All right, we might move on from that, and hopefully that sort of cleared that up a little bit. Brad, I think you had a question, so I'll chuck to you to ask yours.
Okay. Hi, guys. Yeah, just basically, we tried MitoQ early in the piece, and we gave it a fairly good shot, and I must say we didn't actually see any or notice any real difference. And I'm just wondering if you would have any commonly known reasons why people would not respond, and could possibly a hypoxic situation in the brain be one of those reasons?
So I could talk to that. We do have some patients who don't respond to MitoQ, and we're not, to be honest, entirely sure why that is. we have around, say, 20% of people who actually respond extremely well and extremely quickly. Then we have around 60% who respond more slowly and over time, and the response builds. But why that is, maybe it could be to do with the fact that there are different forms of mitochondrial dysfunction, and it could be that MitoQ fixes a good many of them or assists with a good many of them, but there are aspects of mitochondrial dysfunction that MitoQ doesn't have an impact on. Perhaps, Mike, you could add to that.
Again, I think we need to step back a bit and say, of course, people are self-reporting at the moment, and it's anecdotal. So there's a huge number of these anecdotal reports, many of which are positive. But really, we do need fully double-blinded trials to really understand whether when people are reporting good effects, it's genuinely important, it's generally true. So once that's done, then so we do that, we're not certain. But when that's done, I suspect we will find an improvement. And then what we'll find with all of these disorders, with nearly all drugs, especially in neurological disorders, is a range of responses to these many different ways, for ways that are poorly understood. I wouldn't like to comment much further on that because I'm not a physician, I'm just a scientist. But what you'd expect would be that there'll be a range of people responding, and for all the reasons that it's a very complicated situation due to all sorts of differences from patient to patient and from the particular pathology. But what we'd find that works for some people, not for others, is something that most people would predict. But of course, we still need the clinical trials to explore that in more detail.
Can I ask a basic question?
Thanks for that.
Sorry, coenzyme Q10, I understand, is a receiver and a donor of electrons, and that's why it fulfills the role in the mitochondria. So how do you keep the charge over the side, what makes it attracted into the mitochondria when it's actually digested? Why don't you lose the charge at that stage and it just becomes like any other Q10 and difficult to be absorbed?
So the MitoQ and the CoQ10 are quite different molecules. They have the same active bit. CoQ10, this very small amount that gets to mitochondria, will have two jobs in the mitochondria. One, it will take some of the electrons from food and pass them down to oxygen, and it will supplement that movement. But we should have a reasonable excess of CoQ10 inside our mitochondria all the time. The other function of CoQ10 is that it acts as an antioxidant buried in the mitochondrial machinery to stop it getting oxidively damaged. MitoQ doesn't actually do the first job. It can't actually carry electrons in the mitochondria down to oxygen. It only acts as an antioxidant, and it's in a slightly different position. So that's the first point to make. Second is that MitoQ stays largely intact inside the body. So the charge holds it in place, and it's not lost from the molecules. The molecule stays largely intact inside the mitochondria. And small amounts will be degraded later through normal metabolism, but that's as it's being excreted.
Okay. So we've got about 7 minutes to go in our call, so I'm just going to make sure. Justin, did you have any questions that you wanted to ask? I'm sure everyone gets a chance to.
Yeah. Probably a slightly simpler questions after where Andrew's been, but so firstly, I'd like to say you've probably got a customer out of this exercise because I've never heard of this before, and there's seems to be some solid science and some solid experiences that suggest that it's worth giving it a crack at the very least. So it's been a worthwhile exercise. My question would be, is there a different dosage you recommend for people that are trying to mitigate a condition like MS than you might have for a general population that you're putting on the label?
Yeah, we recommend people start with just the regular dose of 10 milligrams or 2 capsules, and just look at doing that for around about a month and just getting a sense of what the product is doing for them. And then we suggest if they want to, they can pop it up to 20 milligrams. And that's again, just, some people find they get extra benefit from that higher level, and some people find they don't, so they pop back down to 10 milligrams and are fairly happy with that. I got some feedback from a a customer of ours just yesterday, and she actually didn't respond too much until she got up to 30 milligrams. So there's a wee bit of a range about where people benefit from, but I can certainly recommend starting at 10, and a lot of people do get a good response just from that.
And does it fully replace just taking a standard CoQ10? So are you able to drop that and pick up MitoQ, or do you lose anything in that swap?
Yeah, from my perspective, for MS specifically, I believe you can swap them out and you don't need to take the CoQ10 on top. Our experience is if someone was taking like 750 milligrams of CoQ10, my experience is around about 20 milligrams is the equivalent, just in terms of the anecdotal feedback we had. And I know, as Mike said, it's very difficult to compare, and I think it'll be different for different people. But that's roughly the equivalence that we are seeing. Yeah.
Thank you.
Thanks, Justin, for those questions. Does anyone else have any questions? Laura or Karen, I'm going to give you guys first preference, seeing as you haven't asked any yet. Laura's shaking her head.
I don't have any.
I convinced her to come and join us. Thank you for joining us. Karen, do you have any questions that you'd like to ask these guys?
I've got one question, which is, Greg, is there any sign that you're going to get trials happening with MitoQ?
Yeah, there is. We had some doctors at a university in America who contacted us around about a year ago. They were having some patients that were getting some that were just coming into the clinic and reporting this swelling of the legs with MitoQ. So they got in touch with us, and they've actually got funding for a trial, and we're just now looking for approval for it. We hope that we'll get an answer this year, and if that goes ahead, then we have a trial which will be for people with MS, and looking at fatigue as the main outcome, but also looking at a range of other results. So yeah, we're basically crossing fingers that that will move ahead.
Right. That's very exciting and fantastic news. I'm going to ask one question that's probably, I guess, Karen, you might even be able to answer this a little bit as well, and we are running out of time, so I'll make these quick answers, but Greg, you could probably start. One of the questions that was asked online is, I guess, for the people who do benefit, Karen being one of these, what's the sort of lag time that you see from when they start taking it to when those benefits are observed?
Yeah, we like to... I guess have people take MitoQ for 3 months and evaluate the process. Everybody responds a little bit differently. Some people will notice something within a week. Other people it takes a couple of months. So just to give it a fair shot and to observe what's happening and what you're feeling from it, I think 3 months is a reasonable amount of time to give it a try.
Is that sort of, Karen, in, I guess we've got about 30 seconds, is that sort of...
Yeah, probably the first inkling was about 10 days into it, but I gave it a full 3 months before I said it was definitely the MitoQ. Yeah.
And I think you sort of mentioned that in the video that's up on Translate at the moment. There were a number of instances across the first few months where you were starting to notice things and said it probably not the MitoQ. It might be the MitoQ. Yeah, it's definitely the MitoQ. So, all right. Well, I'm just gonna wrap this up now as we're about to run out of time. From myself at MS Translate and from all of our community, can we just say a big thank you to Greg and the team at MitoQ, Mike from Cambridge, and also Karen for committing their time to be with us, not only tonight, but throughout the whole process. Greg in particular has had to deal with a number of emails that I've been bombarding him with to get all of the content ready for this week. And I should also mention that it's late at night in New Zealand and it's very early in the morning in the UK. So to Mike for getting up, especially to come and do this extra early for us, thank you very much for that. We all appreciate it. It's been a great success in terms of the week, and we look forward to hear more about how things develop.
Okay. Thank you very much.
Excellent. All right. Thanks, guys.
Okay, thanks, Rick. Bye-bye, everyone.
Bye.
Thank you.
Thank
Bye.
you.